Welcome to this short introduction on what are data. Data are ubiquitous. Data are worth a lot of money. Data may be old, data may be complex. But in the end, what are data? Well, let's have a look at a definition of the International Organization of Standardization. They say data is a reinterpretable representation of information in a formalized manner suitable for communication, interpretation, or processing. So, data are a representation of information. How does this help us? Well, the representation of information, this we can further resolve. There are numerous knowledge pyramids like this, but we like this one because it shows the data as an intermediate element, and what this knowledge pyramid expresses is the way from the basic science up to the knowledge, and the fact that data is representation, or that data is representing information here, is a intermediate step from the science to the knowledge, from the basic elements. So let's have a look at the example here. The basic elements are a bunch of letters which are reordered, or which are brought to an order in the end through syntax, and then from the set of characters we can see, okay, the house is burning. We know, or well, through semantics we can assign meaning to this data. The house is burning means it is hot, means there is a fire. And on our way to knowledge, we have to reactivate our experience, we have to reactivate prior knowledge and create interconnections. And then we know if there is a house that is burning, lives are in danger, and firefighters are needed. So, data is somehow necessary on the way from the basic elements, the science, to knowledge. Let me cite these two sentences. At first glance, data are apparently before the fact. They are the starting point for what we know, who we are, and how we communicate. This shared sense of starting with data often leads to an unnoticed assumption that data are transparent, that information is self-evident, the fundamental stuff of truth itself. And this is really a, central question that we want to answer in this short introduction. We want to know, is data really the fundamental stuff of truth? Is data always true and trustworthy? Where does data even come from? Well, and as usually, we continue by having a look at the origin of the term data, and like a lot of important terms, also this one goes back to a Latin term, dare, which means to give, and datum, which is the participle, is something that has been given. In medieval times, here we can see a medieval letter. Written documents sometimes contained the phrase datum, and thereby became a datum, the content was given. We can see it here and continuing here. And thereby, by this fact that something written became a datum, became something that has been given. This written document captured something ephemeral. And, well, from this state of mind, the current term data really is comes from, because nowadays data are characteristics that are associated to an entity, that are given to an entity. This entity can be an individual, an organization, a location, anything that can be a data object in the end. But, well, entities are data describing entities of the real world are in the end the objects of our empirical research. And now, what is really fundamentally and what is really crucial to understand? This process of associating, or this process of selecting characteristics and associating them to an entity, this process involves human decision. Somebody has to select what characteristic is preserved or what characteristic is represented and how it is represented. So this means data are made. They are not given. They don't come out of the blue. Data are made. And this is really, really crucial to understand. Data come out of a process that involves human decision. And these human decisions, they are made in a certain context. They are made for a certain purpose. The data should serve a certain purpose in the end. And data are basically worthless if you don't know the interpretive context or their purpose. And to become information, to derive something useful from data, you need to know about the original purpose of the data. It is really essential. And now, what happens today? So we now know that data come out of human decision processes in any way. And what happens now is that we observe a modern technological trend which is called datafication. And this trend turns many aspects of our daily lives into data and transforms information about our behavior, about human behavior, into new forms of value. It's really influenced by the digitalization of our daily lives. And the example that we selected here is a Chinese waste disposal station in Beijing. It uses QR codes on the litter bags to create data on every disposal. And of course, there is face recognition to be able to track people and associate it to their social capital profiles. So from looking at the waste, officials can see if people recycle correctly and reassociate this information, well, to an individual in the end. And this is a brilliant example of datafication, which is a process of, well, representing human behavior, human actions as data, and enriching our behavior and actions with context information. The origin of datafication, goes back to, or an example of the origin of datafication, let me put it that way, goes back to Google, for example. When Google, citing this text here, when Google set out to scan the pages of millions of books, it not only digitized the pages, but it also datafied the text, so that letters, words and paragraphs could be read and indexed and searched. An estimated 130 million unique books have been published since the invention of the printing press, estimate the authors. As of 2012, Google had scanned over 20 million titles, more than 15% of the world's books. This data has multiple uses, only one of which is actually reading a book. For example, the project allows scholars to discover when certain words or phrases are used for the first time. The Google project has also been used to facilitate the accuracy of Google's language translation algorithms. This is to exemplify that data will serve different use cases, and that these use cases can be, or most certainly will be, unknown at the time of the data creation. And if you recall the example from the Chinese waste station, this has really severe privacy implications. You don't know what happens to your data in the future. And another example, think of you opting out or taking any privacy measures in your web browser, for example. Even this creates data or provides valuable information to data miners. And now that we know that data, well, is all around us, data is created everywhere, in any situation, basically. Let's turn to the fact, or the observation, or, well, the interesting observation that data even has a social life. And this is to exemplify some of the use cases of data that we maybe are not aware of. This is an example of the Weston Park weather station. It was found in 1880 due to a diarrhea outbreak, and doctors suspected a correlation to the temperature, so they needed data about the temperature and put up a weather station. And this weather station is now associated to the Sheffield Museum. And what is interesting here is that, well, let me just cite a short passage of the work on the social life of data. At 10 o'clock British summertime on 24th of June 2014, two different instruments located at Sheffield Weston Park weather station observed a temperature of 18.5 degrees Celsius. One of these instruments, owned by Museums Sheffield, generated a data point that was recorded in a CSV file. Later that day, a curator at Weston Park Museum uploaded it to an Access database. From here, the curator circulated it in the local community via Twitter, and at the end of the month, it was automatically emailed to the Met Office as part of the station's climate record for June 2014. The second datum was generated by equipment owned by the Met Office and was automatically transmitted by electromagnetic signal to the World Meteorological Organization's global telecommunications system. From here, the datum replicated as meteorological organizations around the world, including the Met Office data center in Edinburgh, downloaded and ingested it into their systems. At this point, the datum replicated again and began to travel down a series of different paths. In almost real time, Met Office weather forecasters in Exeter incorporated the datum into their numerical weather prediction system, and simultaneously the Met Office distributed the datum for a fee to commercial actors such as firms that supply meteorological data to the weather derivatives industry. At a slower pace, the datum also traveled to the Met database synoptic database, from where climate scientists calculated climate averages for June 2014 before saving the data to the MIDAS database to be used by other climate scientists. So, what do we learn from this short story? We can see a social network emerging here, connecting financial markets to the historical Weston Park weather station that we, well, wouldn't really be aware of in the first place. And what does this mean? What consequences does this have? Well, it is important because it shows that data are not only at the time of the creation, but also when they have been created, they are influenced by social and socio-cultural processes. For example, the socio-material constitution of digital data objects. You have to know that the historically constituted values, practices, material conditions continue to have meaning and take on substance in the world. The data curators at the historical weather station, they are totally aware of their historical role, which of course influences them handling the data. And as a next step, of course, this has influence on accuracy, the frequency of the updates, and also the relative power and influence of different actors that are dealing with the data. It also has influence on the data objects. And very importantly, that data, you have to know, or really make this, you have to know digital data is mutable by its nature. Data points may be made temporarily immutable, but they may change at a future point, for example when the next version of a dataset is published, or when cleaning and homogenization is applied, or well, maybe even at different sites. Data is modified in order to generate data sets that are more accurate or more complete than other data sets or whatever. Yeah, but from these observations, the data as mutable mobiles, they connect different human actors in such a complex and often invisible social network. And let's turn to the technical aspects of data creation, which might be, of course, technically trivial, which might be complicated. In the case of weather data, I selected a few examples like the anemometer, which is here on the top left corner. Of course, with such a device you measure the wind force, and the wind causes these half shelves to rotate. And then from the rotation speed you calculate the wind speed. The device here in the top right, in the bottom right corner, that's an ombrometer measuring rainfall. And inside this ombrometer, there is a standardized bowl that fills with rain until a certain weight is reached. And then this bowl tilts and empties itself, and the amount of rain coming down onto a square meter, for example, is then calculated from the number of tipping movements, or the number, how often this bowl empties. And a more complicated example is this SODAR, the sonic detecting and ranging instrument, which is used to measure wind direction and wind speed. These devices, they emit sound waves, audible sound pulses, into the atmosphere, and from there they are received by the device again, because sound energy is reflected by the atmosphere. And then from the reflection, from the intensity and the frequency shift of the reflection, wind direction and wind speed are calculated. And of course these are different forms of technical triviality or complicatedness, but in the end the measurement itself might be flawed by design. And besides the technical details of data creation, current approaches more and more rely on human interactions as data sources. Or, well, maybe this is an example of all the cases that where human interactions serve as data sources. This is an example of chatbots that were trained on the human, or on the interactions they were involved in, and they were on the fly refined on past discussions. The left part is an example or is a research project from Microsoft Research. They had a chatbot associated to a Twitter account, and well, this bot, with this bot you could you were able to chat live on Twitter. And only 16 hours after its launch, Microsoft had to shut down the service because the bot began to post inflammatory and offensive tweets. It became really, really racial. And publicly, of course, through its Twitter account. The right part here, the bot or not, is a research project by Mr. Garvin, who tried to reconstruct how this deviant behavior of the chatbot came from. He recreated a chatbot in a similar manner like Microsoft Research and put it up on Reddit. And also his bot really became racial in a matter of a few hours. And he looked into the data and found that a handful of people spammed the bot with tons of racist messages. And also, although the number of offenders was comparably small, it was an extremely dedicated bunch, and there were and it was enough to contaminate the entire data set. And this, of course, is an example that human interactions, or that data all the time, data comes from the deeply flawed world we live in. Even if we have the best aims and the best things in mind when we create machine learning models and training sets and whatever, data don't have a magic, and they come from the deeply flawed world we live in. And why is this? Well, In the end, the fundamental assumption of the machine learning algorithm is that the past is correct. You know, when you train your machine learning model on on a training data set that was collected in the past, then you assume, okay, this is correct, and anything coming in the future will be similar, will be like the past, or at least it should be. And this is really sometimes, or this is really immoral when applied to certain scenarios. So let me conclude this short introduction. What is the takeaway from our journey? Well, in the first place, data are characteristics that are associated to entities. And what is really crucial to understand is that the selection and the association of characteristics to entities is a process that involves human decisions. Data are made. They do not contain a higher truth. They are made by human decisions. They are under human influence, and as such they may be flawed, they may be irrelevant, they may be outdated, or they may be incorrect. And at the same time, there are digital objects a lot of stakeholders are interested in, and digital objects that may be worth a lot of money. But I think the most important aspect to take away from this introduction is that data don't contain a higher truth, but data are always made by humans.